When we think of flying, the ancient story of Ravana's flying Pushpak chariot or the flying chariot of the sun god surely comes to our mind. What was fiction in those days has been turned into truth today. Today we have made flying vehicles possible, and it happened through the Wright brothers first flying their aircraft on 17 December 1903. Hello everyone, I am Nilarko Pahadi, a student of class 9 from Young Horizons School. When we talk about these fantastic flying aeroplanes and rockets, we often hear a word aerospace. Aerospace, as the name itself suggests, is made up of two words aero for aeronautics and space for spaceflight. Aerospace refers to the study of the atmosphere and outer space. It is broadly divided into aeronautics and astronautics. While aeronautics is the study of the atmosphere and whatever travels within its boundaries, astronautics is the study of whatever is beyond the atmosphere. So, aeronautics includes the study of aeroplanes, helicopters, UAVs, etc., and astronautics includes the study of rockets, satellites, and spacecrafts. Coming to its importance, there are several applications of aerospace, including commercial, scientific, and as well as military applications. Aeroplanes allow speedy travel and communication, while satellites provide us with the internet, which you are currently using to see this video, as well as weather prediction and remote sensing. It is highly relevant in today's tech dependent world. Now let's learn about the different parts of the aeroplane. I will start with the part we are all familiar with, the fuselage or the body of the aircraft. It holds the crew, passengers and cargo. The cockpit is the place from where the pilots control the aircraft. Then there are the wings, which have a lot of intricate mechanisms crucial to the plane's flying. Wings are lift generating parts of the aeroplane. On the trailing edge, there are ailerons for doing roll, while on the inner edge, we have the flaps which increase lift. Slats on the leading edge also increase lift. Lastly, there are the spoilers and the winglets. The spoilers are used to completely disrupt the lift of the aeroplane, while winglets increase fuel efficiency and decreases drag. The wings are very well fabricated to endure stress. Wings generate lift through the Bernoulli's principle. Air moving over the curved upper surface of the wing travels faster and produces less pressure than the slower air moving along the flatter underside of the wing. This pressure difference creates lift, which is a force of flight. Let me show an experiment to show this. This is called the flying ball experiment, commonly found in science museums. The air coming out from the blower is moving much faster than the air around it. Because of the air which is moving faster, it creates a lower pressure zone according to the Bernoulli's principle. The ball stays within the column of low pressure air because of the high pressure surrounding it. The aeroplane wings are also a special shape called airfoil. This shape is aerodynamic as well as beneficial for producing lift. Let us visualize the airflow with an experiment. In this experiment, you can observe that the turbulent airflow around the circle and the square shapes does not occur in the case of airfoil. This shape is aerodynamic as well as it can create lift by the Bernoulli's theorem. Now we come to the empennage or tail portion. We find the horizontal and vertical stabilizers here, which makes the aeroplane stable, while the elevator and rudder helps to maneuver the plane. Lastly, we have the engines producing thrust. It is the heart of the plane. Engines are mainly of three types: turbojet, turbofan and turboprop. Now let's learn about the forces and movements that control a plane's flight. There are actually four forces acting on the plane: the lift acting upwards, thrust acting forward, the weight acting downward, and the drag acting backward. These four forces determine whether an aeroplane will be ascending or descending. There are three motions of an aeroplane: pitch, roll, and yaw. Let's learn about them. Pitch is the rotation along the side to side axis. On the horizontal tail surface, the elevator tilts up or down, decreasing or increasing lift on the tail. This tilts the nose of the aeroplane up and down, causing pitch. Roll is the rotation around front to back axis. On the outer rear edge of each wing, the two ailerons move in opposite directions, up and down, decreasing lift on one wing while increasing it on the other. This causes the aeroplane to roll to the left or to the right. Yaw is the rotation around the vertical axis. On the vertical tail fin, the rudder swivels from side to side, pushing the tail in a left or right direction. A pilot usually uses the rudder along with the ailerons to turn the aeroplane. Now that we know about the flying of the aeroplane, let us learn about the aeroplane instruments. The original 6 instrument pack includes the airspeed indicator, vertical speed indicator, altimeter, attitude indicator, heading indicator, and turn coordinator. They help the pilot to fly the aeroplane safely even in cloudy conditions or at night. In addition to these 6, the advanced glass cockpit features digital instruments. Most commercial aeroplanes use a type of fuel called jet fuel, which is a type of kerosene specifically refined for use in aircraft engines. Jet fuel is a high quality, high performance fuel that is designed to burn cleanly and efficiently at high altitudes. Also, biodiesel and electricity powered aeroplanes are being developed to tackle the problem of global warming and climate change. Aerospace is a very promising sector. Since the aviation and space industry is expanding rapidly, qualified aerospace engineers will be in high demand across many sectors. Yes, aerospace engineering is a challenging field of study, but that shouldn't stop you from pursuing it. This field provides you with many opportunities and benefits that make it all worth it. So, if you want to work in this sector, pull up your socks and start preparing by building a strong foundation in science and mathematics. You can do engineering to get recruited by ISRO, HAL, or private companies. Maybe you can start your own aerospace company. All the best. Before ending this video, I would like to offer my sincere thanks to Spacetrix Aerospace for providing me with such a great opportunity. Thank you.